All right, guys, this is an explanation of the June 2019 Regents exam for Earth Science, and I'm going to go through the entire exam, give you the answers and the explanations as to why these are the correct answers. This is going to be a long video, and I'll put timestamps within this YouTube video so you can scroll through to see which ones you got wrong. And on that note, I would suggest doing this exam first, trying this out as a practice, and then coming back and watching this video later on to see how you did and what you got wrong. Okay, so let's start with question number one. Question number one is a time zone question, and if you read it, it's asking for the time in Boston, Massachusetts. And Boston is shown on the map above, and you can see that it tells you that it's 11 a.m. in San Diego, and it breaks up the United States map into time zones. So if it's 11 a.m. here, we're going to go to Boston, so we're going east. And if you guys remember, if you go east, the time increases, right? East increase. And so I'm going to increase my time as I go across here. So that would mean that every jump is an hour different, an hour more. So this would be 12 p.m., this would be 1 p.m., and this would be 2 p.m. in the Eastern time zone. And so the answer is number 2. Okay? Okay, question number 2. The diagram below represents the spectral lines from the light emitted from a mixture of two gases in a lab, and it's asking for what would happen if this was detected by a star that was moving away from Earth. And the key to this question is that term, moving away from the Earth. And if you remember from class, we said that anything that's moving away is going to be red shifted. In other words, the spectral lines will be shifted towards the red end of the spectrum. And therefore, the answer to this question is quite easy, just based upon that, remembering red stay away, red moving away, and therefore the answer to this question is number 1. Okay? Question number 3. We have a diagram of the Earth and the Moon and the Sun system, and you can see everything's labeled on here. And it's showing you different positions of the Moon going around the Earth. And this question is asking about eclipses, when the Sun and the Moon and the Earth all line up in a straight line. Now, if you remember, a solar eclipse, from our perspective, from Earth, we're looking for the Sun, we're looking for the solar, but there's something in the way, and that would be the Moon. The Moon gets in the way of the Sun. So this position right here, M1, is showing you a solar eclipse because the Sun is being blocked out from our perspective. Okay? Whereas on the opposite side, over here at M2, that would be a position called a lunar eclipse, because now the Earth is in the way, the Sun is shining from over here onto the Moon, but the Earth is in the way, and therefore it's blocking the light out. And so that would be a lunar eclipse. So that narrows down our choices. If we look at all our choices here, we can see that the M1 position has to be a solar eclipse, which means we automatically get rid of answers 3 and 4, because that shows the opposite. And so we want either number 1 or number 2. And if you look at the causes of the eclipse, remember, a solar eclipse is when the Moon's in the way of the Sun. And so the Moon's shadow is going to fall onto the Earth. And you might be in that shadow or not in that shadow. It's a very narrow band. And therefore, the answer to this question is number 2. Okay? All right. That's question number 3. Let's move on to question number 4. Question number 4 shows you a line graph that represents a timeline of events in Earth's history. And basically, it's asking which letter would represent when humans first appear on Earth. And this is one of those questions that you would probably say, okay, I'm going to use my reference table on this one and recognize that this is talking about geologic time. And so this question is a good, ESRT page 8 and 9 question where you can reference this and find this information on page 8 and 9 of your reference table. But this is also one of those, it's just kind of like common sense. Humans are pretty recent in time. If this is the origin of the Earth way back here, 4.6 billion years ago, I'll write BY for billion years, humans are a very small amount of time and very recent to present day. So that would be way over here on the left-hand side. So letter A would be the best representation of when humans first appeared in history of the Earth. Okay? All right, question 5 is all about scale, and this is just kind of one of those common sense questions. You just have to realize the difference between the solar system, basically our planets and the sun, compared to the universe, which is every single star and every single planet and every single thing around us outside of our solar system, which is obviously a lot bigger. So the universe is a lot bigger, and it's a lot older. It's been around longer. Okay, so the answer to that question is simply number 4, just about scale there. Okay, question number 6. Which motion allows an observer on Earth to view different constellations throughout the year? So in other words, sometimes in the winter we can see certain constellations that we can't see during the summer, and vice versa. So why would that be? Why would we have different constellations during the year? So you just have to know what a year is all about. And a year, remember, is all about us going around the sun. So if this is the sun, there's my little yellow sun there, and here's the Earth. Oh, wow, that just changed the color of that. Anyway, it doesn't matter. There's the Earth going around the sun. Okay, and sometimes we can see constellations when we're on this side over here, and sometimes we can see constellations on this side on a different time of the year. It's all about our orbit around the sun. So the Earth orbits the sun once a year, and that's what's allowing us to see different constellations. And so the answer to this question is simply the Earth orbiting the sun. Okay? All right, question number 7 is a question that is definitely a reference table question. You have to refer to hotspots, as it says right here. We have to find hotspots, and specifically this is a reference table page 5. And so I'm going to pull up my reference table to figure this one out. We're looking for the Tasman hotspot in the Pacific Ocean. Now, what I'm going to do is I'm just going to pull this up on my screen here. Here is page 5 of your reference table. And so we're looking for hotspots. And if you remember, hotspots are these like little explosion things right like that. And we're going to look for the hotspot that's called Tasman. And it is located right over in the Pacific Ocean. I'm going to zoom in on that so we can see that a little bit better. There it is. There's the Tasman hotspot. And what I want to make sure that you guys can see is the latitude and longitude, because that's what this question is asking all about. I'm going to draw a line across or straight up from my x-axis, and that's going to represent my longitude. So I'm going to go up from here. That's approximately where we're at, and that's 160 approximately. And my latitude, as you can see over here, is going across this way. It ends up over here right around, I'd say 30 to 40-ish, somewhere in that range. Okay, so if I go back to my responses, let's take a look at our possible answers here. We want something in the 30s to 160, right? And those are all of our choices. So that doesn't really narrow it down for me. So let me just think about exactly what kind of latitude we are. Latitude is on the y-axis of my reference table. So if I go back here, this 30 number is definitely a latitude. And if you notice, I'm south of the equator. So right here is the equator. I'm going south from the equator. So this is a south latitude. So 36 degrees south. I'm going to write that down. 36 south. That narrows down our choices. So let's go back to what we have here. We have 36 south right here. Do any of the other ones have 36 degrees south? No, they don't. So I've already figured out my answer, 36 degrees south, 160 degrees east. Just to prove that that is east, let me go back here. Notice this is the 180 mark. When I'm coming from this direction, I'm coming east from the prime meridian, and that is 160 east right here. This one over here is 160 west. So just be careful mixing those two up. But I narrowed my answer choices just by realizing that that is 36 degrees south. So that's question number 7. The answer is 2. All right, guys, question number 8 is a question that is a reference table question. It could require just some knowledge of the atmosphere, but if you look at it, it's asking about the ozone and where the ozone is found within our atmosphere. Now, if you're not sure, if you have no idea, This is one that you could just memorize, but it's also one that you can use your reference table, because it says right here that the ozone is found between 10 and 20 miles above the Earth's surface. And so we need to figure out what zone of the atmosphere that is in. And so if you look on your reference table, specifically, let me show you, it's going to be on page, hold on one second, page 14. And you can see right here the selected properties of the Earth's atmosphere is right here. And so we're looking for an altitude of 10 to 20 miles above the Earth's surface. So here's 0. This side of the reference table, if I zoom out, the right-hand side is in miles. So this is going to be our mile scale here. We have 5, 10, 15, 20. Okay, so we're up to, there's 10 and there's 20 miles above the surface. 20 is there, 10 is there. And so we are in this layer called the stratosphere. And so the answer to this question, simple, is just the stratosphere. Okay, so that's all based upon your reference table, but it's also one of those things that you can memorize. Okay? All right, question number 9, the Coriolis effect. This question is one that it's going to require memorization. You have to know what the Coriolis effect is and what it's caused by. And that's what this question is asking about. What is it a direct result of? And so you just have to know this one. The answer to this question is the fact that the Earth spins on its axis once every day. And so the answer is number 4. And remember that that spin of the Earth, so as it spins around on its axis around once a day, is going to cause the wind and thereby the oceans to curve one way or the other depending upon which hemisphere you're in. And therefore, you might get a question about the Coriolis effect about the northern hemisphere, which I'm shading here in red. The northern hemisphere, it spins counterclockwise, okay, curves to the right. And in the southern hemisphere down here, it curves to the left. And so that's just one of those things you're gonna have to know and memorize. And that's a question that might be tricky just because it requires recall. Okay, so that's number 9. All right, question number 10. The question is asking for the dew point. What is the dew point if the dry bulb temperature is 18 and the relative humidity is 64%? This is a little bit of a tricky question, but this is a reference table page 12 question. So you're going to need to get to your reference table, page 12. And just before I go there, we have 2 numbers that we're working with. The RH value of 64%, relative humidity, and a dry bulb temperature, I'm going to say dB, of 18. So just remember those 2 numbers, relative humidity 64, dry bulb 18. So I'm going to go to the reference table. Okay, so we know the relative humidity, which means we actually have to start on this chart over here. Okay, so we know relative humidity is 64%, dry bulb is 18. Well, that would be over here. So here's 18, and I'm going to come across from there until I get to 64%, which is right there. Now that doesn't tell us much, but it does tell us what the difference between the two is. 4 is the difference between the wet bulb and the dry bulb. And I'm going to use that information, and I'm going to go up to the next chart up above, the dew point chart. So remember now we're dealing with 18 and 4. So I'm going to go up to the next chart up here and say, okay, where is 18 and 4? Here's 4, and here's 18, and I'm going to come down from there, and I'm going to come over from 18, and that's going to give us our answer of 11 degrees Celsius for the dew point. So it requires using both charts. And let's go back to the actual test. And now we know that the answer is number 2, 11 degrees Celsius. So a little bit of a tricky one, but it's, again, just straight from your reference table. All right, question number 11. Question number 11 is also a reference table question, but the first thing we have to do is figure out, okay, we're changing liquid water into water vapor or a gas. So we need to figure out what is that change from liquid to gas called. And you're just going to have to recall this one. It's something that you'll have to memorize. Going from a liquid to a gas is called evaporation. So I'm going to write that down, evaporation. And that's key because if you know that, then you can figure out the answer to this question. It requires using your reference table, and specifically ESRT page 1. It's right on the front page. There's a whole chart of changes that water does as it changes from phase to phase. And so we need to find the one about evaporation. So we're going to go to the reference table, and we're going to look for that chart. It's right on page 1. It says properties of water, and specifically evaporation, or in this case, it says vaporization. Vaporization is the overarching term. And it says that it gains energy in order to change, right? If you want to go from a liquid to gas, you got to gain, it's got to heat up. And the total amount that it gains is 2260 joules per gram. So gaining 2260, go back to the test, and you'll see we're talking about gained, right? 2260, the answer has to be number 3. All right, number 12. Number 12 is a question that's related to this picture of the water cycle and water falling from the sky onto a surface, and it's, as it says, infiltrating into the ground, and then it's going down to this zone of saturation down below called groundwater. And what the question is asking is, what is this line represented by the X right here? What is the top of the zone of saturation? And this just requires recall. It's like memorization here. There's no reference table that you can go to for this one. You just have to remember that the top of that zone of saturation, where the water is underground, is called the water table. Okay, so that's the surface of the zone of saturation. So that's it for number 12. All right, question number 13, index fossils. So index fossils are on your reference table, page 8 and 9. So you might want to flip open to page 8 and 9 of your reference table, and recognize that there's a whole bunch of them on the bottom. They all have pictures of them. Now, this one is asking for an index fossil that came from a marine environment. Marine environment means underwater. You have to know what that word marine means. It's going to pop up in other places as well. So underwater, swimming underwater, or living underwater. Now, if you just kind of think about some of these, you might already know that a condor is a bird. It's not going to live underwater, so you can immediately eliminate that. You might also know that a mastodont is like a woolly mammoth. That lived on land. That's not underwater. So you can almost get rid of those two immediately. Now, these other two you might not be sure about. So you might want to look on your reference table on page 8 and 9 just to see what they look like. So Eosporifer and Colephysis. So I'm going to look for those names on my reference table. Page 8 and 9 are here. And I'm going to look for Colephysis. There it is. It's this letter L, dinosaur. And you would expect that that thing probably did not live underwater. And by the way, there's the mastodon right there. Okay, so you know that didn't live underwater either. So it can't be the Colephysis. It's got to be Eosporifer. And if you look for Eosporifer, it's on here. And it's way over here on the right-hand side, letter Y. It's like this shelled organism. It kind of looks like a mollusk or some kind of clam of some sort. And so that would make sense that that lived underwater. And therefore, going back to the test, the answer has to be number 3. Okay? All right, number 14 is a meteorology question, and you can see there's different pictures, different diagrams here representing different types of weather fronts. Now, the way to identify weather fronts is by looking at what's moving in. What's coming in from the left-hand side? All these arrows are moving from left to right. What's coming in from the left-hand side, and what's happening as a result? So if you look at this one over here, letter A, you'll notice this is cold air that's moving in, and it's pushing this warm air out and pushing it up because it stays nice and low to the ground. So cold air in would make sense that that would be a cold front. And you just got to remember that a cold front has a curved line, cold curved, okay? So that would make sense to say that A is a cold front, which immediately gets rid of number 2 as well as number 4. And then let's see what about letter B here. We have warm air moving in and going up over and top of the cold air. And so that would make sense that that's a warm front because you have warm air moving in. And therefore the answer is still either 1 or 3. It doesn't really tell us because both of those have warm front for letter B. So we have to look at letter C. So if you look here, we have cold air moving in, like a cold front, and we have cool air moving out, but this warm air is being lifted, okay? And if you remember that, that is when a cold front catches up to a warm front, and when they catch up to each other, we call that occluded. It's almost like included. They got smashed together. And so the answer to this question is number 1. This is just one of those where you kind of have to know your weather fronts. A stationary front would have warm air on one side, cold air on the other side, and nobody's really going anywhere. It's stationary, it's not moving. In this case, we see a whole bunch of movement, so it doesn't make sense that that is stationary. Okay, so the answer to number 14 is 1. All right, number 15 was a pretty famous question from June 2019. I remember seeing this for the first time and saying, why did they do this to you? This is a question about Michigan, not even New York State geology here. But anyway, it's not as bad as you might think, but there is a word in here that's maybe a little bit confusing. So first off, we want to know what caused the formation of this Michigan Basin. If you read this, the Michigan Basin is just like this dipping down of these lines. You can kind of see they're all curving down and then back up again. So it makes kind of a bowl shape. Now, what process is responsible for pushing down on all that stuff? What's that idea all about? Well, you kind of have to look through the choices here. First off, uplift means going the opposite way, meaning like going up like a mountain. So it's definitely not uplift. We're going down. Faulting, you guys might recall, is like when you have an earthquake and you have one side that lifts up and the other side lifts down. And we don't really see a fault line in any of this picture, so that would not be faulting. Okay, so we got rid of 1 and 2. Number 3, metamorphism. Does this have anything to do with metamorphic rocks? Well, it tells you right here that these are all sedimentary rocks. There's no metamorphism going on. There's no major pressure and heat going on in this diagram, and it doesn't really make sense to have metamorphism. So the answer is down warping. Now, the reason that was weird is because I never taught that. I don't think any other earth science teacher taught about down warping, but that's kind of the idea of this pushing downward of these sediments due to more and more piling up on top. And so you have this downward movement and that dipping down of this basin due to the pressure from above. Okay, so the answer to question number 15 was 4. All right, number 16 is all about the orographic effect. If you remember this from meteorology, that's the idea that on a mountain range, when you push air up and over a mountain range, it's going to cool down and form clouds, and you're going to have a lot of precipitation on one side, and you're going to have very little precipitation on the other side. And so if you take a look at this diagram, we can see the prevailing winds are coming off the ocean, bringing that moisture off the ocean. And as they push over this mountain, the air starts to cool down. And when you have cooling, and that's a key word here, cooling, you are going to condense all of the moisture, all the water vapor that's in the air from a vapor into a liquid. And remember, that's what forms a cloud. And so cloud formation is due to the fact that we're lifting all of the air up in this location. And as a result, when you form clouds, you tend to have a lot of precipitation. And so it's going to be nice and rainy on this B side of the mountain. Whereas over here on the other side, where C and D are located, it's going to start to warm back up again, and it's going to be nice and dry over here. So the answer to this question is like, where do you have cloud cover and where do you have precipitation? Well, that would be where you lift it up to a higher elevation on that prevailing wind side. So the answer is number 2. All right, number 17, which Earth's surface would absorb, and that's key, which one's going to absorb the most radiation or incoming solar radiation on a sunny day? So you got the sun shining down on the surface. We'll just draw it in red because it's going to change anyway. Okay, it's shining down on the surface, and we want to know which one's going to get the hottest, really. Which one's going to absorb a lot? Well, that would be true if that was a really dark surface, right? Because dark colors tend to absorb more. And if it's kind of bumpy and rough, right? So darker colors, rougher surfaces tend to be better absorbers. Opposite of that would be better at reflecting the light and would get wouldn't get as hot. So we want to absorb a lot, so we want something dark colored. And if we look at all our choices here, the best choice is number 1. And you can just think about like your blacktop driveway on a sunny day. It gets pretty hot. Okay, so that's number 17. All right, number 18 is all about absorbing infrared radiation. And this is one of those questions that's kind of disguised as a weird question, but it's basically asking you what's a greenhouse gas other than carbon dioxide and water vapor. And this question, I think I told you about this, you need to know more than one greenhouse gas. And in this case, you really need to know 3. You need to know that obviously water vapor is a greenhouse gas, obviously carbon dioxide is, and one more. And if you recall on this one, you would know that methane is the answer to this question. These other gases that are listed here are not greenhouse gases. Oxygen and nitrogen make up a majority of our atmosphere. Hydrogen is barely anything, and they don't absorb as much energy as methane does. Okay, so the answer to that question is 4. All right, number 19 is a reference table question. It's asking for a geologic time period. So you know that's going to be reference table page 8 and 9. You got to use really both of them to figure this one out. Okay, and we want to know when Washington State was closest to the equator. So you have this picture of North America here, and we want Washington State to be basically close to the equator. And that's going to happen in history sometime, probably a long time ago, not recently. So let's take a look at our reference table, page 8 and 9. I'm going to pull that up here. And if you look on the far right-hand side, you'll see these maps of North America and where it is in time. And you'll notice as you go farther and farther back in time, like down at the bottom of them all, especially this picture right here, this one that is, I'm going to circle here, you'll notice that Washington State is really close to the equator, okay, in that northwest corner of the United States. So that would be way down here at the bottom of our chart. So we're talking during this time period. So I'm just going to follow that across. I'll draw a line so you can see this. I'm following this bar across this way. And if I go a little bit farther over, you'll notice that that is the Ordovician time period right there. Okay, so I'm going to go back to my test and take a look at the answer choices. The answer has to be number 4. Okay? All right, question number 20. A climate event that occurs when surface water in the eastern equatorial area of the Pacific Ocean becomes warmer than normal. So this is a meteorology idea related to some climate stuff. And remember, this is one of those questions that you really just have to kind of memorize and know. And we can just go through the choices here to figure out our answer, but it is kind of a memorization thing. Air mass formation happens everywhere. This is very specific. This question is very specific to a certain region. Air mass formation happens all over the place, over continents, over water, so it can't be number 1. The Doppler effect is related to astronomy, the idea of things moving and redshift and blue shift with their spectrum, so it's not that. El Nino is the answer to this question, but just to tell you, monsoons are all about like extreme amounts of rain in a short period of time, so it's not a monsoon. The answer is El Nino. That happens approximately every 7 years or so. There's a warming of the Pacific Ocean, and it changes the climate, even in New York State, even though it's happening in the Pacific Ocean off the coast of South America. So the answer is number 3. All right, question 21 is a reference table question, and specifically you're going to be using pages 8 and 9 of your reference table to figure this one. It's all about geologic history, and so you have the indication of geologic periods there. That's what this is all about. Now, just to kind of give you an idea, this is one of those pain in the neck questions where you have to go through every single choice to figure out what the correct answer is. We're looking for bedrock in the New York State rock record. That's kind of the key to this thing, and that's what we're going to be looking at on page 8 and 9. And we want no bedrock. It says no sediment or bedrock in New York State rock record. So let's kind of go through the choices and see what we have here. First off, we have Cretaceous and Quaternary periods. So if I look at my reference table, let's check. Here's the New York State rock record. Specifically, what I'm pointing to is right here, okay? And you can see that those little areas where we have a record are shown by these little blocks that are right here. So this first one, if you kind of take a look at that, the Quaternary time period is definitely shown, okay? And you can see right here the Cretaceous time period, hold on, sorry about that. Cretaceous time period has a little bit as well. And so that definitely has a rock record. And we're looking for no rock record, so it can't be number 1. All right, Paleogene, Neogene periods. We got to find those on page 8 and 9. Let's take a look. Paleogene, Neogene. Here they are. Actually, you know what? Let me go back and erase all this stuff. Here's the Paleogene, Neogene. Let's see if there's any rock record over here. You'll notice there's nothing. There you go. That's got to be the correct answer. There's nothing, no evidence of that time period in New York State history, and therefore that is the correct answer. I won't even go through all the other choices because I've pretty much narrowed it down. You can look through the rest of them and you'll see that there is a little bit, but the answer is number 2. All right, guys, question number 22. This is a question that we talked about in the classroom about correlation. We have two outcrops here, and we have to kind of match them up to figure out which one is the youngest. And I'm going to do that, and you might recall me doing this in the classroom with some of the notes that we were taking. So let me just show you this. We have these two outcrops. I want to find something that's matching across them, some rock type that's matching. And so if I match them up, I'm going to bring outcrop number 1 over here. And you'll notice that I'm kind of matching up that rock type right there. So if you look at that across the board here, these two are matching, these two are matching, and these two are matching. So now it's all matched up. The one letter that is highest would be the youngest. Remember, at top, the top is always the youngest. And so in this case, the youngest is definitely letter A. And technically, this rock layer, this sandstone at the top, is really the youngest. But we'll say A is the youngest because it's on top. I had to correlate to do that. And so the answer to this question is number 1. Okay? All right, question 23 is all about drainage patterns. And these are a little bit tricky just because you have to recognize where the water is flowing. I'm going to just change my color to blue just so I can demonstrate where water would be in this diagram. What you're looking at, or what you're looking for, are valleys. So you can see a hill, and then you can kind of see the valley is where I'm drawing the blue line there. And here's another valley, and they're kind of connected right through there. And there's another connection that goes through there. There's probably a valley over here in this region that you can't really see. But all of these long rivers are all parallel to each other. Very long, straight rivers that are connected. And so what you're going to look for in the possibilities are just long parallel rivers, and that would be answer number 3. The other ones don't really show that parallel drainage pattern, and that's called a trellis pattern. The other ones don't really work for that situation. Okay, so the answer is number 3. Okay, question number 24. We're comparing a landscape that's in a cool, dry climate to one that is in a warm, rainy climate. So what would it be like in a warm, rainy climate? Well, you'd have a lot more weathering and a lot more erosion. And so we would expect that the landscape would erode a lot faster, so we can get rid of number 1 and number 2. And because it's a weathering and eroding, it's going to break everything down and round everything out, and therefore the answer has to be number 4. Okay? All right, number 25. This is actually a reference table question, believe it or not. It's asking about the type of bedrock that's found at the Mid-Atlantic Ridge. And you guys probably remember that the Mid-Atlantic Ridge is right in the middle of the Atlantic Ocean. It's a very tall mountain range underwater. And so where would we find this information? Well, it's actually on page 10 of your reference table. So let me show you that. It is right here. So here's page 10, the Earth's interior. It shows you different layers of the Earth, and specifically right here at the top right-hand corner is the Mid-Atlantic Ridge. Now remember, the Mid-Atlantic Ridge is right in the middle of the ocean, and therefore it is made from oceanic crust, which has a density of 3.0. So there it is, Mid-Atlantic Ridge, 3.0 basalt. And therefore I'm going to go back to my test, and the answer has got to be basalt with a density of 3.0. That's answer number 2.